This chart shows the global nut market's trajectory, hitting $5.9 billion in 2022 and tracking a steady 5.4% annual growth heading toward 2030. Notice this specific segment driving the upward curve. That's the Asian market. That upward momentum is coming directly from a massive surge in the commercial snack industries across China and India. But if we look closely at what these consumers are actually buying, we hit a botanical technicality. Most of the foods driving this multi-billion-dollar market aren't actually nuts. Take a look at an almond growing on a branch. That fleshy green hull makes it a drupe, exactly like a peach. Pistachios are drupes too. Cashews are technically seeds that grow outside their fruit, and peanuts develop underground as legumes. We group all of these distinct plants together on grocery store shelves for one practical reason. They share an identical, highly lucrative nutritional profile defined by extreme fat density. This diagram breaks down the volume of a standard nut. The water, protein, and carbohydrates make up a relatively small fraction, while a massive 76% of the total weight is purely lipids or fat. Yet, dietitians and doctors consistently recommend this highly caloric, fat-heavy food for cardiovascular health and weight management. The benefits don't come from the volume of the fat. They come from the specific microscopic architecture of the lipids themselves and the unique chemical compounds trounced inside them. To understand how these specific plants conquered the global agricultural market, we have to look past the shell and examine the molecular mechanics operating inside. We can sort the major commercial nuts into distinct categories based almost entirely on the shapes of their fatty acid chains. This matrix visualizes our first group, almonds and cashews. They are packed with monounsaturated fatty acids, specifically oleic acid, which protects the cardiovascular system by neutralizing bad cholesterol. Walnuts shift the profile entirely. They are concentrated in polyunsaturated fatty acids, relying on linoleic acid. Embedded within these distinct fat structures is a secondary health mechanism, bioactive volatile compounds. These are trace chemicals, like phenols and terpenes, that float within the lipid matrix. These trace chemicals act as powerful anti-inflammatories and help regulate blood glucose levels, which directly lowers the risk of developing type 2 diabetes. In their raw state, these kernels provide a direct combination of healthy fats and anti-inflammatories that target the specific markers of metabolic disease. But we rarely eat them raw. The global supply chain relies heavily on intense processing, subjecting the harvest to roasting, to deep frying, and industrial oil extraction. This processing does have culinary benefits. Intense heat degrades fatty acids into volatile compounds like hexanol, creating the rich, toasted flavor and aroma consumers expect. That same thermal energy, however, accelerates the oxidation of those delicate polyunsaturated fatty acids. This introduces a chemical threat known as isomerization. The intense heat physically mutates the fatty acid, forcing the molecular chain to snap into a rigid configuration. This mutation converts healthy fats into dangerous trans fats, creating a spike in lipid oxidation markers. By relying on traditional high-heat roasting methods, the commercial food industry trades long-term cardiovascular health for short-term flavor. Because these specific lipid profiles are so highly valued, international agricultural trade has essentially become a competition over fat molecules. The United States maintains a near monopoly on oleic-rich drupes, generating 79% of the world's almonds and 63% of its pistachios. China commands the PUFA-rich crops, producing 51% of the global walnut harvest and 38% of all peanuts, while simultaneously serving as the highest consumer of both. Meanwhile, India and West Africa dominate the cashew and peanut markets. These regions also control unique, deeply cultural species, like the kola nut, which carries an incredibly dense antioxidant profile. The global trade map effectively follows these botanical boundaries, where a nation's export power is built on the specific fatty acid chains its climate can produce. Global consumer demand is steadily moving away from empty calories and heavily processed snacks. Shoppers are now looking for functional foods, items that provide measurable clinical health benefits. To capture that growing market, producers have to rethink their manufacturing lines. By adopting standardized low-heat processing methods like vacuum frying, the industry can successfully preserve those delicate volatile compounds. If we can preserve their molecular structure, these crops function as a specialized delivery system for human health.